Hi, my name is Matthew Barker. I am a solutions architect for Sonatype. Today I'm going to talk about what goes in must come out, hidden defects in your software application. You can find me on LinkedIn and Twitter, and I do encourage you to tweet Twitter using the hashtag shown here. I have a lot of fun in my job. I get to travel around the country, meet with companies, talk to their DevOps practitioners, build tools, architects, security people, and talk about software quality, software innovation, software efficiency. Now, I say I have a lot of fun at that. I guess that sort of makes me a nerd, but hopefully I'm not alone in this audience. So in my conversations with companies around the country, I find that a lot of software operations are very concerned and scrutinize the code they're writing, what I would call the custom code. They do code reviews. They often scan the source code for security vulnerabilities and quality issues, and they work on best practices around that code. What they often fail to scrutinize and pay attention to is, in terms of this analogy, what lies beneath the surface. 20% of a typical app is custom code, and 80% is what? By the way, I have some giveaways for people that answer some of these questions. Can anyone tell me what I'm referring to when I say the hidden 80% of an application that's not the code that your developers are writing? Framework? Open source. Yeah, open source components. I'm going to dive into that hidden 80% and give you insight into what's there and how you can effectively manage it. I'm going to borrow heavily on Sonatype's State of the Software Supply Chain report, where we analyzed 3,000 organizations and 25,000 applications. How many components were they using? How many components were they downloading from public repositories? What was the quality of those components? Those are the kind of things that we'll explore today. So a story that kind of comes up over and over again. This is not atypical. This is a major healthcare organization that we analyzed. This organization downloaded 16 million components last year. That's a lot. It's hard to get your arms around that. But it turns out there was only 5,000 unique components, excluding multiple versions of the same component, like of a framework. They might have downloaded 10 versions of a framework, but only 5,000 unique components. What about the quality? As it turns out, 1 out of every 25 components they downloaded had a security vulnerability. A lot of their applications were mission-critical apps, public-facing, and security vulnerability leaves them open to a breach, which you hear about all the time in the news. Now, I hope some of you are paying enough attention to wonder why there's a photo of Dick Cheney on this slide and the smirk that he's got. Well, I'll get to the reason why I have Dick Cheney here in just a minute. But when I was looking for photos of Dick Cheney, I found a whole bunch. And it turns out there's multiple photos available where he has the same smirk. And I calculated 1 out of 25 photos on the internet have him smirking. The same exact ratio as the number of security vulnerable components this healthcare organization downloaded. Coincidence? I think not. So back to Dick Cheney. The reason I highlight Dick Cheney is you may not be aware, but he had a heart transplant, and they implanted a pacemaker to monitor his heart. It's pretty common practice these days with medical devices to include a Bluetooth interface. It's sort of consumer demand driven. But can you imagine a breach when it comes to a Bluetooth device, a medical device? In this case, Dick Cheney's security team was so concerned about that they had his doctor disable the Bluetooth device. So the reason I mention this is We think of security vulnerabilities and breaches as causing great financial harm. Well, they can cause as bad as human life as well. So it's an important topic. Now, the analysis from Sonatype's research is that a typical app is 80 to 90% open source. What you can think of is that software is no longer written, but is assembled, manufactured from parts. This is a good thing. If you're a developer and you need to encrypt your data, you don't want to become an expert on encryption. You just want to download a component that will allow you to encrypt your data. XML parsing, framework, web frameworks. You don't want to reinvent the wheel, so you use open source. It's a great thing. In fact, it's such a great thing that it is actually driving massive productivity gains. Companies are leveraging, they say software is eating the world. Well, open source is eating the software world. It's causing such great productivity gains that companies such as Uber, John Deere, and Salesforce are leveraging software to become leaders in their field. In fact, Uber, a major player in the transportation industry, has dominated that industry without owning a single car. Unfortunately, there's risks in using components that you didn't write. No matter how good you are at producing quality code, secure code, if you bring in components, your application is only going to be as good as your components. The DevOps movement has borrowed heavily from the manufacturing industry. The next big borrow is just the realization that you have a software supply chain. Your suppliers are the open source teams producing components available for consumption at public repositories. The public repositories are the warehouses. So repositories like Sonatype Central Repository, PyPy, Ruby, etc., Docker. All of those are your warehouses. Your manufacturers are the software development teams at the different companies producing software, consuming these components. And the finished goods are the applications. Now you may notice here that there is a bit of a circular production pipeline going here in that you're producing software applications. Those components are often fed back into the open source as suppliers. Okay, so given that we have a software supply chain, what is the best way to manage it? How many here have heard of Edwards Deming? Raise your hands. Okay, if you're in DevOps and you haven't heard of Edwards Deming, I would suggest you Google him, do a little research and look him up. His quality principles changed the entire economy of a major country, Japan, and brought them out of the post-World War II depression they were in. Well, I'm kind of dating myself here, but when I was very young, made in Japan meant cheap. And now Sony, Toyota, Honda, when you think of Japanese products, you think of quality. The principles of Edwards Deming is the ones that enabled that. The principles he espoused can be put down into 3 simple principles. Use the fewest and best suppliers. Identify those good suppliers, utilize them only. Second one, choose the highest quality parts from those suppliers. And then lastly, track what you use and where. Have a bill of materials for every one of your applications. Can you imagine what would happen in the automotive industry if they didn't do this? If there was a safety problem in the brakes for a particular car or set of cars, if they ran things like the software industry, they would publish that defect in a website. And every consumer would have to go to that website and figure out if that affected a component in their car. That's how the current security vulnerability system works today for software. We need to move to a model, imitate the best practices from the automotive and other manufacturing industries. Obviously, yes. And that it's plugged in fine. All right. Got it back. Okay. So obviously, we're feasting on a massive supply of open source components. I mentioned the producers, the OSS project teams. How active are they? Well, there's this great site called Module Counts. It keeps track of new components being available on a daily basis. Turns out there's 1,000 new projects per day being published. 10,000 new parts available per day. And each part, on the average, is updated 14 times a year. So that's the producers. The consumers, we estimate there's 10 million developers worldwide, and there were 31 billion downloads from the central repository. Obviously, there's other repositories, but that is the largest warehouse of open source components in the world. 31 billion downloads in 2015. Anyone good at math? How many components per developer does that work out to? About 3,000, 3,100. I imagine this guy on the bike's carrying about 3,100 boxes. And if you look closely, he's sweating pretty bad. Think of this guy as indicative of your developers. What do you think the likelihood of him crashing here is? The consumption rate is huge. Developers want to do the right thing, but they can't keep up with the massive scalability of what they're expected to do. They want to do the right thing when it comes to security, license, and quality, but it's really hard to keep up with this kind of rate. And of course, not all parts are created equal. I don't know how many here have heard of the 10,000 eyes, the theory of the 10,000 eyes. The idea is that if so many people are looking at it, that it has high quality and it's secure. Well, I'm here to tell you it's completely false. Many components have poor quality, poor performance, and security defects. In fact, there are vendors that are better than others. The age of the component has a lot to it. Newer components are usually better than old. There are many with risky licenses. There's lawsuits every month when it comes to license infringement, open source license infringement. And of course, a lot of them are buggy. There are quite a few, though, that are exceptional. So the key here is how can we identify those exceptional suppliers and parts? Okay, any app security experts in the audience? Anyone? DevOps, security is everyone's responsibility. How many have heard of OWASP Top 10? Okay. So another chance to win a giveaway. I've got 3 pictures here from the OWASP Top 10 site. They correspond to 3 vulnerabilities from the top 10. Anyone have any idea on any of them? SQL injection, he was the first one. All right. How about this one on the top right? It's the hardest of the 3. What's that? It's related to authentication. It's cross-site forgery, which, absolutely. Very good. Please claim your prizes. So, now, of the 31 billion downloads from last year, what we found is in 2014, 6.2% of them had security vulnerabilities, like SQL injection, like cross-site scripting. In 2015, there was 6.1%. I don't know, as a statistician, I find that pretty much insignificant. What kind of bothers me as an app security expert is that we made almost zero progress from 2014 to 2015. The whole process of publishing vulnerabilities and getting that information to developers is completely broken. It's not the developer's fault. The CVEs or vulnerabilities, they're published per app, not per component. It's really difficult to determine which components have the vulnerabilities. So you need a good solution to help you do that. Now, 31 billion, you might say, who cares about 31 billion downloads? Let's focus on, with our report, what we were able to do is give an average per organization. Over the 3,000 organizations, the average organization downloads almost 250,000 components per year, about 5,200 unique components from 2,000 suppliers. That's a lot of suppliers. To give you an idea, Toyota Prius uses fewer than 150 suppliers. Toyota is one of the top quality. They're the ones that implemented Deming's principles, and they understand using the fewest and best suppliers, and it results in a higher quality product. So there's problems here. Now, what about the quality of those components? Well, as it turns out, 6.1% of the downloads had known security vulnerabilities. Doesn't sound like a lot, but an average app has 100 components. So that means on the average, each and every one of your apps, if you're not paying attention to this, has 6 components with vulnerabilities. And it only takes 1 to enable a breach. So this stuff's pretty important. When I talk to companies about these kind of numbers, they're actually surprised about the volume of open source they're using. They know they're using open source, but they had no idea that it was this kind of volume and that the defect ratio is so high. So you can think of the open source, use of open source components as a huge innovation wave, carrying you to productivity gains, delivering value to your organization, delivering software, making you a leader in your market like Uber. But the trick here is to be able to ride that wave without it crashing down on you, causing you financial harm, and in the case of our friend Dick Cheney, physical harm. Didn't happen to Dick Cheney, but they were worried about it. Okay, so how can we do that? How can we leverage this innovation in a safe and secure way without getting burned in the process? So let's go back to Deming's principles. Use fewer and better suppliers. What makes a good supplier? One is that they produce parts of high quality. Functionality basis, on a maintenance basis, it's good parts. We actually are doing a decent job of this. Developers pretty quickly realize which suppliers produce parts that perform well, that aren't buggy, that have the features they need. That's not where the problem is. What's more of a problem is, do the suppliers, are they able to produce components that are secure? One of the gentlemen up there mentioned frameworks. I happen to know 2 of the major popular web frameworks out there is Struts and Spring. And they're both from Apache. But the Spring team, their recent versions, going back 10 or 12 versions, going back a year, pretty low defect rate, much lower than the typical 6%. Whereas the Struts team, it's about double the average defect rate. They have not yet quite mastered the ability to produce secure components. If you end up using struts, that means your web app is insecure. Now, there are good versions of struts, so I'm not recommending you don't use struts. I'm just saying it's a little harder to find a good version, and I would keep a close eye on it. New versions tend to have no security vulnerabilities, but maybe 3-6 months down the road, it gets vetted and they discover vulnerabilities. The last thing, the way to evaluate a supplier is every supplier is going to have problems. There's going to be problem components. How quickly do they remediate that? What's the mean time for remediation? That's something to look at as well. But I have to say, being an older guy and starting out as a developer, developers are getting younger and younger these days. It's getting kind of ridiculous. Okay, the second Deming principle is pick the highest quality parts from those suppliers. But what makes a quality part? I like to say components that age like milk, not like wine. They don't get better with time. So typically, as a rule of thumb, newer components are better than old. In fact, the defect rate for newer components is half that of older. I do have one caveat to that suggestion is using a very recent version may not be the best idea because it hasn't been vetted yet. It hasn't been hardened through use. So I would recommend you pick a component, a year old or so, that has high quality and is secure. The license for the component is important. You hear about license infringement lawsuits all the time, intellectual property risk. One that's not mentioned, that's not shown there, is AGPL. If you use an AGPL component in your app and you host that app, so if it's a web app, you are by terms of the license agreement required to release all of your source code. So the license obligations are very important to keep track of. And then the code. Does the part come with source code? I know some companies, they have a policy, we're only going to use an open source component if the source code is provided. So those are just some of the factors that make a good component. You may have your own strategy of what makes a good component. The important thing is that you seek out and find those good suppliers and find those good components from them. Now, this is a DevOps conference. My wife's a realtor. In the real estate industry, they say location, location, location. In DevOps, it's automate, automate, automate. Let's go back to the Titanic. You remember in the Titanic when the ship was going in the dark, in the fog, and they had that guy on the crow's nest with the binoculars, and his job was to see the iceberg and make sure he would sound the alarm and the ship would avoid the iceberg. Well, whenever I see that scene, I think I'd hate to be that guy. Well, think of that guy, the equivalent in the software industry, as your security compliance officer, who's in charge of maintaining the security of 20, 30 apps. So he's not just the one guy on a ship, he's one guy trying to stop your ship from hitting an iceberg, but 20, 30 ships. It just doesn't work, it doesn't scale. You need to automate. You need an automated way to avoid bad components and an automated way to choose better ones. So I highly recommend that. Now the last part of Deming's software supply chain principles is to track what you use and where. To have a bill of materials for each and every one of your applications. Let's go back to that automotive recall analogy I used in the automotive industry. So we have the same thing in the software industry. If you have a company like PayPal has thousands of apps deployed. If there is a vulnerable component, let's say when they deployed that apps, all the components were good. And then a year or two later, a known vulnerability gets reported on a component that they know is in some of their apps. Without a bill of materials for each of their apps, How easy is it to determine which apps it's in? Without a tool to allow them to find a better version quickly, how quickly can they do that software recall? So it's important to have a bill of materials to handle a recall. We're going to talk here in a minute about compliance. Compliance is coming where a lot of companies and government agencies are going to require a bill of materials for all your apps. So let's take a look at that. So at the White House, they are working on cybersecurity laws constantly. They're going to require a bill of materials for all software delivered to government agencies. OWASP's top 10 already has don't use components with known vulnerabilities. That's going to be part of the compliance requirements as well. And then the idea that as a software vendor, you need to be able to provide fast and quick patches when there is a problem. That's going to be another requirement. That's one of our things that evaluate a vendor, right? They remediate problems quickly. That's all coming. I'm going to quickly cover this case study. Major global insurer decided that they wanted to increase the efficiency of their operations, improve the quality of their releases. They gave specific goals. They wanted to reduce their defect rate down from 10 defects per 10,000 lines of code. They wanted to improve the efficiency and productivity of their developers by 15%. And they wanted to be able to handle a software recall efficiently. So those were their three goals. They applied Deming's principles to their software supply chain. By using better and fewer suppliers, they reduced their defect rate from 10 to 4 by 60%. By using the highest quality parts, they reduced that further from 4 to 1. So by applying those first two principles of software supply chain management, they got a 10x reduction in software defects. They implemented having a bill of materials for all of their apps in development and production. And they were able to handle the equivalent of recall efficiently and avoid a lot of rework. So what was the final results? Their defect rate dropped by 10x. Their developers, they were pleasantly surprised that they exceeded the 15%. Their developers were 30% more efficient. Just coincidentally, Deming has said that the average worker is 30%, spends 30% of their time in non-productive work. And of course, they were able to efficiently handle a component recall. If you'd like to get more information on the stats in my talk, it's available at our website, Sonatype, SSC 2016. I want to thank you all for joining me on the discovery of your hidden defects in your software application. I wish all of you a more positive outcome than the Titanic's fateful outcome. Smooth sailing, avoid those icebergs, and manage your software supply chain. Thank you. We have time for one or two questions. No questions? You guys got all of that? All right, thank you for your time.